Hi, welcome back to the training on the Apollo oil lubricated air compressor. Today we're going to go ahead and look at the compression cycle electrical schematic. Now this is the electrical portion of the compressor, and we're going to go ahead and look at how these components all interact together to run the air compressor. Now right here we have a control box, and there's several items that are inside of it, and we'll go ahead and talk briefly about what those items are. If you have any questions, go ahead and comment down below, and we'll dive a little bit deeper into some of these items if you need it. The first thing we'll talk about is the supply voltage, which is 240 volts. That voltage is coming into one side of the compressor control box. Then we have what's called a contactor. A contactor is a device where you control a large voltage with a smaller voltage. In this case, we're controlling 240 volts with 24 volts. Now, the way that we get that 24 volts is we use something called a step-down transformer. This step-down transformer is converts 240 volts into 24 volts. And then we have a circuit protective device called a fuse. The fuse is there in order to protect against an overcurrent situation. And then we also have a wall on-off switch that is a low voltage. It's a 24 volt switch, and this is for locating the switch somewhere further away from the compressor. And then this prevents you from having to run 240 volts through your wall to a switch somewhere else. So basically, we'll just dive right in here, and I'll kind of try to illustrate how things are laid out. The supply line voltage is always present on one side of the contactor contacts. So we have supply voltage coming in. It goes here to these two contacts. Now you can imagine these contacts as being basically almost like parallel bars going through here, except they're open right now. It will be closed, but when it's not activated, this is basically this opens and closes. Now, the line voltage is also being supplied to the 240 volt, 24 volt transformer, energizing it. So the transformer's here, and so you have a parallel circuit. So you have your 240 volts going to the contactor as well as to the transformer. Now, I've gone ahead and illustrated the 240 volts in green. No particular reason why, just it's a different color. Now, the transformer supplies 24 volts through the fuse to the on-off switch on the wall and to one side of the 24 VAC contactor coil. Now, what that looks like is this. So we have the voltage going through the fuse to the switch, and then from the switch to one side of the coil. All right. Now, when the on-off switch is turned on, the position of the contactor coil is energized, closing the contacts. So there's also this other side of the transformer goes to the other position here. So you have 24 volts controlling 240 volts. So when that voltage is applied through the wall on-off switch, there will be voltage going through the actual contactor. So this voltage makes it through and then over here, and it goes out to the unit. Now, with the contact closed, the line voltage is supplied to the fan motor, energizing it, and at the same time, line voltage is supplied to one side of the vac unit on-off switch. So now, when what they're trying to say is that this voltage, now this fan right here is usually the same voltage as the unit itself. So it'll either be 240 volts or 120 volts. So when and I don't really like the way they have it drawn here, but basically the way I'd see it is when the unit is on, this is basically supplying voltage to this fan to run it. That's how we'll look at that. At the same time, the voltage is supplied to one side of the on-off switch, which is right here. Okay, so we'll kind of go like there. Okay. Now, when the vac unit on-off switch is turned on, the line voltage is supplied to one side of the pressure switch. And so if that's on, you basically have that voltage going there to a pressure switch. Now, what the pressure switch does is if the pressure is less than 80 psi or 85 psi, it will go ahead and close. So when this switch is closed, it is telling the pump motor, the compressor, to turn on. So the contacts are closed. So we'll just imagine contacts being, and I'll just say what they mean by contacts is there's basically a line and there's like a little door, and that would be a depiction of a open contact, and then this would be a depiction of a closed contact. And so depending how you control that, it's either open, so that would be greater than 85 psi, and then it would be closed, which is going to be less than 85 psi. Hopefully that makes sense. Line voltage is then supplied to the compressor, energizing it. So this is basically just going to go through here to your compressor, turning it on. So just to kind of show you, the line voltage basically is making it through all of this, through here, through this switch, through the pressure switch, and then to the compressor. So you're beginning to see a path. And this path, understanding this path is really important for troubleshooting, because this is what allows you to divide the system up. And if you have a specific problem, you can actually replace that part, or you could repair that part. So it's also supplied to the normally open solenoid valve, closing the valve, preventing the compressed air being discharged to the condensate drain assembly. So at the same time that everything is being supplied to the compressor, you have a parallel circuit that comes up here, and this is a normally open solenoid. And this is really important because when it's energized, it's not going to allow the air to escape from the piping on the compressor. Vice versa, when this pressure switch closes, the solenoid valve that's normally open returns back to an open state and allows air to bleed out of it and allows the purge cycle to happen. The system will continue to run until the pressure inside the system reaches 100 plus or minus 5 psi. And so again, that's controlled by the pressure switch. And it says, note, the compression and purge cycles will continue as the pressure inside the system fluctuates between 80 and 100 psi. And so for these compressors, what you can expect is you can expect for the compressor to start at 0 psi, and then you're going to basically have three readings, three places. You're going to have 100, okay, and then you're going to have 80, okay, and you're basically going to, the compressor is going to turn on in the morning, and it's going to go all the way up here, and it's going to stop at 100, and then you're going to use the air, and then it's going to go down to 80, and it's going to turn on, and then throughout the day, your compressor will continue to turn on and off. And this is what you're hearing. Okay, so your compressor is always going to be above 80 pounds of pressure, except when it's off in the morning. So, and then this will happen indefinitely until you turn off the compressor at the end of the day. Now, something else to keep in mind. So this switch right here is located on the compressor itself. And this switch right here is located on the wall up in your area. So this is a switch you're going to use to turn on and off the compressor in the morning. So hopefully all this makes sense. If you have any questions, please let me know. Again, this is Jason from the Dental Equipment Repair Channel, teaching you about the Apollo oil lubricated air compressor. Thank you.